Factoring, Part 2. If we look at our first example, we have a trinomial, 3 terms, and we need to factor this trinomial. But in order to factor this trinomial, we first need to factor out a monomial. Mono means 1, so we're going to factor out the common term between these 3 terms. If we look at our coefficients, 8, 28, and 60, 8, 28, and 60 all have a common factor of 4. And if we look at our variables, x to the third, x squared, and x, all of these terms have an x in them. So the monomial that we need to factor out first is 4x. Now when I factor 4x out of all of these terms, I'm left with 2x squared minus 7x minus 15. And I could check this answer by distributing this 4x back into the parentheses. At this point, I need to factor what I'm left with in the parentheses. I'm going to leave the 4x out front, and I'm going to factor this trinomial. Two things that multiply together to give me 2x squared are 2x and x. And now I need to look at the factors of 15. Well, the factors of 15 are 1 and 15 and 3 and 5. And I need to pair those numbers up with 2 and 1 so that my middle term will be negative 7. Well, if I put a 5 here, this 5 will be paired with this 2. Now if I put a 3 here, this 3 will be paired with this 1. So if I have 10 and 3, I can make 10 and 3 7 by making this negative and this positive. Now when I FOIL, I would have 2x times x, 2x squared, 2x times negative 5, which is negative 10x, plus 3 times x. So I'd have negative 10x plus 3x. That'll give me negative 7x minus 15. So in order to factor this trinomial, I first factored out the monomial, and then I factored the remaining trinomial. Let's look at example 2. Here we start with a binomial. And if I look at my coefficients, I have 3 and 9, so I can factor out a 3. And if I look at my variables, I have x squared and x. So I'm going to factor out an x. And I'm left with x minus 3. I could check this by distributing. 3x times x is 3x squared minus 3x times 3, which is 9x. At this point, I'd want to factor x minus 3. But x minus 3 already is factored. I can't factor it anymore. So to factor this binomial, I just need to factor out a 3x. This is as far as I can factor this problem. The next topic we're going to cover is solving by factoring. So far we've just been factoring expressions. They're expressions because we don't have an equal sign in them. Now we're going to move to problems where there is an equal sign. In order to solve by factoring, we need to use the zero product property. The zero product property says this: if I have two things being multiplied and my answer is 0, one of those two things has to be 0. So if I look at this first problem, if I want to solve for x, my first instinct would be to add 8 to both sides, and then maybe try to divide both sides by x, Well, that doesn't get me anywhere. So maybe I need to divide by 3. Again, that really doesn't get me anywhere. So I kind of have to go back to square one and look a little bit closer at this problem. The reason I can't solve for x directly in this problem is that I have x twice in this problem. I have an x squared and an x. And no matter what I do, I can't just solve for x directly. Instead, I need to use the zero product property. I already have this set equal to 0, so I want to keep that. And I want to rewrite this trinomial as something times something. I want to rewrite the trinomial as something times something. So how do I rewrite a trinomial as a product? Well, in order to rewrite a trinomial as a product, I need to factor. Two things that multiply together to give me x, 3x squared, are 3x and x. And now I need to look at the multiples of 8. And I want to get 5 for my middle term. I already have a 3 here, so if I pair that 3 with a 1, and I pair this 1 with an 8, I'm going to have 3 and 8. And 3 and 8 can turn into 5. And I need a negative 5, so I want this 8 to be negative and this 1 to be positive. Now if I FOILed, I would have 3x squared plus 3x minus 8x, which would give me negative 5x minus 8. So if I look at this problem, I have something times something equaling 0. And I can use the zero product property. One of these two somethings has to be 0. Either 3x minus 8 is 0, or x plus 1 is 0. One of those two things has to be true. If I look at what I'm left with here, I only have one x in this equation, so I can solve for x by adding 8 to both sides and dividing by 3. So one of my answers is x equals 8/3. And I only see x once in this equation, so I can solve for x by subtracting 1 from both sides. If you notice, I actually get two answers for x. X can either be 8/3 or x can be negative 1. The clue that tells me that I have two answers for x is this power right here. Whatever this power is, that will be how many answers I will have when I solve for x. Let's look at example number 4. In order to use the zero product property, I need to set this equation equal to 0 by adding 7x to both sides. Now, I want to use the zero product property, so I need to rewrite x squared plus 7x as something times something. To rewrite this as something times something, I need to factor. And if I look, both of these terms have an x common. So I can factor out an x and be left with x plus 7. If I distributed this x back into the parentheses, I would have x squared plus 7x. So these two are equivalent. So how do I use the zero product property in this problem? Well, I do have two things that are being multiplied together. My first thing is x, and my second thing is x plus 7. So my choices are x equals 0, or x plus 7 equals 0. Solving for x, I'm already done in this first equation, and in the second equation, I just need to subtract 7. So I still get two answers, x equals 0 or x equals negative 7. It's just I only have one term here. I only have a monomial. Again, the clue that tells me I have two answers is this x squared. This power will tell me how many answers I need. The last problem we're going to go over. The area of this shape is 36 units squared. Find the value of x. Well, this shape is a trapezoid. And the area of a trapezoid is 1/2 times the height times base 1 plus base 2. So in this problem, my height is x, my base 1 is x plus 2, and my base 2 is 3x. And I know that my area is 36 units squared. So I need to plug in what I know into this formula. 36 is my area, equals 1/2 times my height, times base 1 is x plus 2, plus base 2 is 3x. At this point, I need to solve for x. To solve for x, I'm going to combine like terms inside my parenthesis. Now, to get rid of these parentheses, I need to distribute. And I need to distribute this whole monomial. This is really 36 equals 1/2 x times 4x plus 2. So I need to distribute this 1/2 back into the parentheses before I can solve. 1/2 x times 4x is 2x squared, plus 1/2 x times 2 is x. Now at this point, I need to solve for x. And the highest power of x is 2. So in order to solve for x, I need to use the zero product property. So I'm going to set this equation equal to 0 by subtracting 36 from both sides. And I'm left with 0 equals 2x squared plus x minus 36. I'm going to rewrite this trinomial as something times something. I'm going to have a 2x and an x, and I have a whole bunch of multiples of 36, but I need them to pair up to give me 1 for my middle term. I could use 1 and 36, 2 and 18, 3 and 12, 6 and 6, but the one that I want to use is 4 and 8. Excuse me, 4 and 9. Because if I can pair that 4 with this 2, then I'll have 8, and then with this 9, I can make a 1. So I'm going to put the 4 here, and that'll give me 8, and I'm going to put the 9 here, and with an 8 and a 9, I can make 1 for my middle term. And I want this 1 to be positive, so I want my 9 positive, and my 4 to be negative. So now I have two choices. Either 2x plus 9 has to equal 0, or x minus 4 has to equal 0. and I need to solve for x in both cases. So x has to equal -9/2, or x has to equal 4. Well, if I look back at the original problem, algebraically I get two answers. This x squared, this 2, tells me that I should get two answers. But if I look at the problem geometrically, x can never be a negative number. I'm never going to measure this height or this length and get a negative number. So geometrically, the correct answer is 4. Algebraically, I get two answers. I just need to look back at my problem and pick the one answer that makes sense.